We're going to begin our detailed coverage of barrier synchronizers in Java by first exploring the structure and the functionality of the Java CountDownLatch. And we'll start out by taking a look at how it's structured and what some of its high-level behaviors are. So the CountDownLatch implements one of the several forms of barrier synchronization that are available in Java. And this particular implementation allows one or more threads to wait for the completion of a set of operations being performed in other threads. So one example of this that we've touched on earlier was the starting gate in a horse race, or the starting blocks in a foot race, where all the horses or all the people who are the runners are going to be in position before the race begins. You wouldn't want one horse to start before the other ones. You wouldn't want one runner to start before the other ones, unless you're racing against Usain Bolt, in which case you want to give everybody like a 20-yard head start, and he'll probably still win. The CountDownLatch is very well supported for fixed size, one-shot entry and exit barriers. And you'll see why it's really only useful for one shot as we get into more of the details. It's not designed for use as a cyclic barrier. So you can't use it for cyclic barriers. You have to recreate the CountDownLatch again, which is doable, but usually misses the point. And so if you need cyclic barrier semantics, use the cyclic barrier class. The CountDownLatch also doesn't implement any interface. So these are all just sort of standalone classes. They don't have an implementation of lock or condition object or condition or whatever. Interestingly enough, the implementation of CountDownLatch uses a variant of the bridge pattern, which, as we've seen many times before when we've talked about things like reentrant lock or semaphore or other things like reentrant read-write lock, these allow the abstraction to vary from the implementation hierarchy so that they can be changed without breaking stuff. You can have different implementations. For example, you can have fair and non-fair semantics with a semaphore or with a reentrant lock. This particular implementation uses the bridge pattern, but it doesn't go as far by having different implementations. So it's kind of a lobotomized version of this. The way this works under the hood is there's a sync implementer hierarchy, and this inherits functionality from the AbstractQueuedSynchronizer class. And as I mentioned before, it's not quite as full-featured as what we would expect with reentrant lock or semaphore. Instead, it doesn't have this fair versus non-fair semantics. It just uses it basically for letting a group of threads be released when the count drops to 0. So it uses the state of the AbstractQueuedSynchronizer to represent the count. And then it takes advantage of the semantics of AbstractQueuedSynchronizer to know when to release the waiting threads when the count drops to 0. So that's the end of the overview of the structure and the functionality of Java CountDownLatch. Of course, we'll go into more examples of its key methods and an application of this in just a minute.